In the previous section, we learned the dot product of the two vectors. In this section, we will learn another product, which is called cross product. For the given two vectors, A and B, A1, A2, A3, and the vector B is B1, B2, and B3. Okay, the cross product of the two vectors has been defined like this: I, J, K. Okay. This is just a notation. Okay. You put A1, A2, A3 in the second row, and B1, B2, B3 in the third row. Okay. Then this is like a determinant. Okay. So if you cross the first row and the first column, then you end up with a 2 by 2 determinant: A2, A3, B2, B3. I, that's a plus, a minus, okay, minus. This time you cross the first row and the second column, then you got a 2 by 2 matrix: A1, A3, B1, B3. Then this is a coefficient of J. Then plus. Then you got another 2 by 2 matrix by cross the first row and third column. You got A1, A2, B1, B2, which is a coefficient of K. Then perform the determinant of a 2 by 2 matrix. Then you got A2, B3 minus B2, A3 times I minus A1, B3 minus B1, A3. This is the second component, the J. Then plus A1, B2, then minus B1, A2. That's for the K. If you want to write as a form in the triple, you got first component is A2, B3 minus B2, A3. Second component is you have minus. Okay. Therefore, minus and minus, I write this one first, give you B2, A3 B1, A3. Okay. Minus A1, B3. Okay. Then the third component is A1, B2, and minus B1, A2. Okay. This is the for the given vector A and B. This is the definition for the cross product. Okay. Then you may wonder why we want to define the cross product in such a complicated way. Okay, first of all, I want to remember the cross product for the two given vector as a result is a vector I call it C. Okay, you can see there. See, this is with result is like a vector with 3 components. Very most important application of cross product is, okay, if you have two vectors A and B, the cross product gives you the third vector. This third vector, if you call it C, and the vector C will perpendicular to the vector A at the same time. This resulting vector will also perpendicular to vector B also. Okay. So if this is A, this is B, okay, then this one will perpendicular to both of this vector. Okay, this is a cross product. Okay, you're going to see later. This is have lots of application. We need to find a third vector perpendicular to the given two vectors. Okay. Remember, for the dot product, we have a formula like this. A dot product B is equal to the magnitude of A and the magnitude of B, then cosine theta. Theta here is the angle between A and B. For the cross product, we have something similar. Magnitude of A, magnitude of B, then sine theta. Theta again is the angle between vector A and B. Okay, we know this is correct. Okay, look at this second equation. Do you think this equation is going to be right? Look at the right hand side of the equation, which is a scalar. Okay, look at the left hand side, which is cross product of A and B. Give you a vector. So vector cannot be a scalar. So this equation is not right. You have to add the magnitude. Remember that. Okay, now remember theta is the angle between vector A and vector B. If theta equal to 0, if theta equal to 0 or pi, then your right hand side is 0, right? Which implies magnitude of A cross product B will give you 0. Okay. This is a vector. Its magnitude is 0, implies this vector is 0 itself. Okay. So what that means? That means if your vector A and B, they have same direction, the angle between them is 0, then the cross product gives you 0. And also if A is like this, B is opposite, okay, then that means the angle is pi. Then sine pi is still 0, means if you combine both cases, just tells you if vector A parallel with vector B, then the cross product must be 0. If two vector dot product give you 0, means A perpendicular to B. Remember this. The cross product give you 0, means they're parallel. Okay. Now, for the dot product, we have this. A dot B equal to B dot A. Okay. How about for the cross product? What is the relation between A cross product B or B cross product A? Okay. If you go back to the definition, the A we put in that determinant. A is the second row, B is the third row. The order is important. Okay. So if you change the order A and B, that means you change your you put your A in the third row, B is in second row. If you make a calculation, you're going to see this is a negative of that. So let me draw you a picture. Okay. If this is A, this is a B. Okay. Then A cross product B give you a vector like this. This is this vector. Okay. And B cross product of A give you the one with the same magnitude but opposite sign. I strongly suggest you to read a book. Okay, that will picture show you how which sign which direction to go. Okay, now let's look at some examples. Now I give you two vectors. U here is I plus J plus K, and the V here is 2I plus K. Okay, here's a question. We want to find two unit vector perpendicular to. Okay, we're looking for two unit vectors. Let's give a name. I call W1 and W2. They're both perpendicular to given vector U and V. Okay, I give you vector U and vector V. Okay, how many vectors you can find perpendicular to both of them? The answer is infinity. U, V. Okay. How many vectors? You have something like that and a different magnitude. There's infinite many. However, only have two vectors. They're perpendicular to both of them, but however, the magnitude is 1. So one is like this, one is like this. Okay. So before we find the W1 and the W2, first we just find any vector perpendicular to both U and V. So I give you U and V. How do you find the third one perpendicular to both of them? That's exactly the application for the cross product. So the W should be U cross product V, which means this really, if you write as a triple, is 1, 1, and 1. And the V there is 2, 0, and 1. Okay, so you have I, J, and K. You got a 1, 1, 1, and a 2, 0, 1. So you write this is 1, 1, 1, 0, 1, 1. Okay. Cross the first one is across the first row, first column. I minus cross the first row, second column. You got a 1, 2, 1, 1. This is a J plus cross the first row and the third column. You got a 1, 2, 1, 1. Okay. So you can write as the first determinant to give you 1, second one give you 1 minus 2, so give you minus 1, with another negative sign give you positive 1. The third one, 1 times 1 minus 2 times 1, so give you minus 1. Okay, so we find a W. W here is 1, 1, and the negative 1. So what we can say W? W is one of those vectors perpendicular to both of them. That's what the property of the cross product is. So let's find the W1. W1 has the same direction with the W, but with unit, with magnitude 1. So to find this one is like you just need divided by its own magnitude. This is scalar times a vector. So magnitude of W is 1 square plus 1 square plus 1 square times W. Okay. So you got a square root of 3 times 1, 1, and the negative 1. So I'll give you this. Okay, what we can say about W1? First of all, W1 have same direction with W, which is perpendicular to U and V. Second, W1 have a unit length. Okay, so we can find the W2. Just W2 is the same as W1, but with opposite sign. So it's minus W1, which gives you minus 1 over square root of 3, minus 1 over square root of 3, then positive. You can check W2 is perpendicular to both U and V at the same time, magnitude is 1. Okay, let's look at one more example. Okay. Now, this example I give you 3 points. 1, 0, 0. Q there is 0, 2, 0, and R here. R there is 0, 0, 0, and 3. Okay. Now, what we want, okay, as you know, 3 points will be uniquely determine a plane. Say P, Q, and R. So you know those 3 points uniquely determine plane. Now we're looking for a vector perpendicular to this plane, which means out of my board. Okay. So that's what we want to find. Okay, we want to find a vector. Find a vector. Say W, perpendicular to the plane. Determined by 3 points, P, Q, and R. Okay. So how do we find such a vector? Remember, we have to do the cross product will do that. So first of all, we have to find the 2 vectors on this plane. We can easily find vector PQ and vector PR. Okay. PQ vector. How do we find a vector PQ? Use endpoint coordinates, subtract starting points. So PQ, use 0, subtract 1, then 2, subtract 0, then 0 minus 0. So give you minus 1, 2, and 0. Then PR. Use the coordinate for R, subtract coordinate for P. Z minus Z, 0, 3, minus 0. Okay. Minus 1, 0, and 3. Then perform the cross product. As a result of cross product, give you another vector we call it W. And this W will perpendicular to both of the vector, which means perpendicular to the plane. Perpendicular plane determined by P, Q, and R. You know how to calculate this sense. Okay, so I'm going to stop here.